All right, question number 13. We want to find the limit as x approaches -4 of the function 4x squared plus 7x minus 8 divided by 6x minus 4. So we have a rational function, and again we are going to solve this by doing direct substitution. The only thing we got to make sure is that the denominator is not equal to 0. 4x squared, 7x minus 8, and then we have a 6x minus 4. Okay, so to see where this limit is tending toward, we will plug in a -4 and evaluate this function. And then we have 6 times -4 minus 4. Okay, so when we square -4, we get a positive 16. 16 times 4 will give us 64. So this will equal 64 positive. 7 times a -4 will give us a -28. And then we will subtract the 8. So I can combine the two negatives, and this will give us a -36. And then if we subtract 36 from 64, that should give us 28. And let's double check that. Where's our little calculator? All right, so we're going to say 64 minus 36. We're looking for 28. Okay, so just double check. So we have a positive 28 on top, and on the bottom, 6 times -4 will give us a -24, minus 4 will give us a -28. So we end up with 28 positive on top, -28 on the bottom. When you divide, we get a -1. So we would say that the limit of this function as x approaches -4 is going to -1. And we have another rational function, and so this one, just upon looking at it, so we're going to have to employ one of our other methods, one of our algebraic methods, which is factoring, because when we want to evaluate the limit as x goes to 7, immediately I look at the denominator. I want to make sure we're not dividing by 0. So if I plug in a 7 for x, I get 7 minus 7, and I get a 0 on the bottom, which that's a problem. So with this problem, we're going to need to employ a different method, and it looks like we can factor this function. So we have x squared minus 49 divided by x minus 7. So if you notice on the top, this can be factored by using difference of squares, and so that will give us a x plus 7 and then x minus 7. And then on the bottom we still have our x minus 7. So all together we can factor out the x minus 7 divided out, and what that would do is just cause a hole in the graph where x will be equal to 7, because you got to do a little algebra. But anyway, we'll find the limit of this function now that we've simplified it. And so if we do direct substitution and plug in a 7, we get 7 plus 7. We get 7 plus 7, and then that tends toward 14. So we would say the limit of this function as we get close to 7 is equal to 14. But maybe the value at 14 doesn't exist, the x value. The y value is getting close to 17, but maybe when we plug it in, it doesn't exist. That is what we did, right? X plus 7, x minus 7, we cancel out. We plug in the 7 on the top. Oh, they want me to simplify it first. So it's 2 parts. Okay, so we're going to say x plus 7. So first they want me to simplify it. And then want us to find the limit.